Since ancient times, this has been our view of Jupiter. Without a telescope, looking up at the sky, we can see Jupiter among the stars, and the fact that Jupiter is a planet is something that is a remarkable thing to think of when we look up and just see it in the sky as we do now. But the advent of the telescope allowed a new view of Jupiter, and Galileo discovered 4 moons of Jupiter in 1610, and this is a composite of images taken over about 2 days. And this is fairly much how he could see them through his small telescope, and how people can see Jupiter through a small telescope now. And we have the moons Io, or Io, Europa, Ganymede, and then the faintest one out here is Callisto. It comes in out here. And so, if we want to go further and say, what do we know more about Jupiter by getting up close and looking? Jupiter in 1973 was visited by Pioneer 10 that flew by Jupiter, and it became the first spacecraft to cross the asteroid belt and fly past Jupiter. And one of the remarkable things that it found at Jupiter was that there's a strong radiation field around Jupiter with lots of high energy particles, and an environment indicating that Jupiter has a very strong magnetic field. And so we can see the great red spot here that has been seen continuously since the time of Galileo, more than 400 years ago. Here's a view of Voyager 1 as it approaches Jupiter in 1979 over a few months. And we can see it is not a stationary, static place. It's an atmosphere filled with hurricanes and storms, different colors, and the winds are going at great speeds in both directions, east to west and west to east. And the swirling great red spot is seen here. So Voyager 1 and its follow-up Voyager 2 discover Jupiter's faint rings, seen here. This is the disk of Jupiter, and lightning strikes are seen here. And these were seen at a time when the spacecraft looked back at Jupiter, looking at its dark side, after getting some fantastic pictures of the front side, the sunlit side. So this is the night side of Jupiter. These were discovered looking at the closest of the larger Galilean moons, the 4 large Galilean moons. The closest one is Io, and it is spewing a volcano there that was discovered by the Voyager missions. We can also see the very strange, colorful features that indicate lava flows on the surface of Io, or Io if you like. An infrared image of Jupiter, a series of images, shows that heat is coming from the interior of Jupiter. One of the things that we have to realize about Jupiter is that the planet is still condensing through gravitational contraction, and because of its gravitational contraction, it is getting hot and releasing energy at a level greater than the amount of light that it reaches from the sun. And so we can see a lot of the same structure in the infrared light that we saw in the optical light. In 1994, a comet called Shoemaker-Levy 9 collides with Jupiter. After first being broken into pieces on a nearby approach, it went out again and then came back and collided into Jupiter, into the southern hemisphere. On the left, we see the Galileo spacecraft images of the comet just before impact on Jupiter. And Galileo was not at Jupiter yet, but it was on its way. The picture on the right are the marks, the kind of bruised-looking marks left over from about a day after the impact, seen with the Hubble Space Telescope on the southern hemisphere of Jupiter. This Galileo spacecraft was not a flyby mission, so the Pioneer and Voyager, both Voyager spacecraft, were flyby missions. They took pictures and took data for a number of days and flew on by on the way to other destinations. And so the Galileo was a dedicated orbiting mission, and it dropped a probe into the interior of Jupiter in order to study its pressure structure and composition as it fell. It observed a lot more lightning. As we can see, these are lightning strikes. The Galileo spacecraft infrared telescope observed the ammonia and other kinds of chemicals associated with the Great Red Spot. Jupiter's rings were found to be made of dust, very likely kicked up from meteoroids that smashed into Jupiter's innermost moons. And these rings do seem to be associated with the moons that are inside, orbits inside of the Galilean moons. So closer in than Io, Europa, Ganymede, and Callisto. And these rings seem to be from collisions with objects with those moons. There was another collision of an asteroid or comet seen in Jupiter's southern hemisphere. It occurred July 20th, 2009. So it's very clear from this evidence of looking at Jupiter just for a little while close up that objects hit this giant planet frequently, and these are the type of collisions that would be ultra catastrophic if they occurred here on Earth, or when they do occur here on Earth. So the Cassini mission was on its way to Saturn. Its mission was not to view Jupiter, but it did observe, and there are some fantastic pictures. And here is a picture of the Great Red Spot. Here's a picture of the southern pole of Jupiter. This was the first view of the polar region. And Cassini also took this series of pictures that were made into a movie showing the very fast motion of the clouds. So this is the entire, or nearly the entire surface of Jupiter, except for the poles, stretched around so that you can see all the way around the planet at the same time. So we can see the Great Red Spot. A lot of these things are moving east to west. Some are moving west to east as well. And very strange features that are occurring along different bands and zones in this photograph. So the aurora of Jupiter, indicating a strong indication that there's a magnetic field and a magnetic north pole here of Jupiter, is shown by the aurora, and this is taken using a Hubble Space Telescope image. Jupiter's aurora were also observed by the most recent spacecraft to visit Jupiter, and that is Juno. And this is an observation of the aurora as Juno flies over the pole. And Juno also has a visible camera that showed the Great Red Spot and a lot of the structure in the cloud layers. The color here is not true color, but it is color that has been added to try to bring out features associated with the clouds and such on Jupiter. And this was done by using a citizen scientist project for Juno. Finally, looking at the structure, as far as we can tell, we can't see into Jupiter, but as far as we can tell, the structure is such that there's a rock core. There may be some ice in that rock and metal core here that is 5 to 10 times the mass of Earth in that core alone. Although we're not completely sure exactly, that's what the models indicate. Metallic hydrogen exists in the mantle above that through most of the structure of the planet. Hydrogen is the main constituent. Helium is the second most common element, and very similar to the sun. And the compression and pressure down in this region causes the hydrogen to form a metallic structure. Above that, we have a layer of liquid hydrogen as the pressure is less, and then finally gaseous hydrogen, and then the cloud layers of about 50 kilometers thick. These cloud layers are where we see all the weather and all the things that I showed you in the previous images. And there's probably some rain in the form of helium and neon falling as it falls through these layers of liquid hydrogen. There are some rings. There's the halo ring, and the main ring, and the Amalthea Gossamer ring, and the Phoebe Gossamer ring, which are associated with those inner small moons. Also, you can see the aurora in the south polar region, aurora in the north polar region. Here, the magnetic field would extend to something like 10 or so radii, or diameters of Jupiter. We see the Great Red Spot has been here for 400 years at least. It's been here since as long as humans have been observing it. Although it has changed in strength over time, it has not gone away. So that basically leaves us with a Jupiter in a nutshell.